Right, so here we've got a car and a trailer, alright, connected by a rigid tow bar. Given lots of information you can see I've filled in my force diagram already. But what you'll notice I've done is I've just looked at them as one object, okay? Because they are connected, aren't they, by a rigid tow bar. Okay, so rigid means that it's tight. Okay, it's not as if it's a rope where it gets slack and so on at times. No, it's tight. So we could think of this as one entity. So one entity, then I combine the masses, yeah? So 1500, 600 comes to 2100. So the weight be 2100 G. And as always with the vertical plane, with an inclined plane question, I'll have the forces resolved perpendicular to the plane and parallel to the plane. In terms of the weight here, that's important because the weight is acting vertically downwards. So I needed the component perpendicular and parallel to the plane. The combined resistances, notice I got 700 newtons there because 400 for the car, 300 for the trailer. And of course then this tractive force of the engine, okay, 8,400. That's what the engine is producing. They're giving me the angle in terms of sine. Sine alpha is 7/25. So remember sine is opposite over hypotenuse. So O/H. So that's why I've got that there. So then also then of course then we can get cos alpha. Okay. That will be adjacent over H. Now that side there will be 24, right? If we use Pythagoras, 24/25. Okay. So if we now then look at working out the acceleration, that's what they want there in part A. All right. So we'll use Newton's second law. Okay. In the direction of motion. Okay. So the direction of motion means it's going up the inclined plane. So we've got 8,400 taking us forward. Take away then the resistance, which is 700. We'll also take away the 2,100 G sine alpha. Okay, and that will equal to then the mass, which combined mass 2,100 times then the acceleration. Okay, so it's a simple case then of subbing in sine alpha, okay, G is 9.8, sine alpha is 7/25, and you can get your acceleration from there. So let's work up that left hand side. So we got 1937.6 equals 2100. So A then be 1937.6 divided by 2100. Not too many zeros there. Right. So I get that's out to be 0.92. What did they say? 2 decimal places? No, 3 decimal places. So 0.923 meters per second squared. 3 decimal places. Okay. So we've established the acceleration of the car they want, which of course will be the same as the acceleration of the trailer, okay, and the tow bar, everything, because this one body is connected. So that's the acceleration there, and we've done what we've asked for. Now in part B it says determine the tension in the tow bar. So focus wants to be on this tow bar here. So what we can do now, right, we could stop now, think of it as one whole object, right, and we can sort of zoom in a little bit, okay, and you can zoom in on the car and the trailer if you want, the car and the tow bar if you want, or you can zoom in on the trailer and the tow bar, and that's what I've done. I've actually gone for the trailer, right, and so I've drawn my diagram already here, okay. I've thought about just the trailer alone, because if you just think about the trailer, okay, then you know, the forward force, then think about what's pulling this trailer forward. It's the tension, isn't it? Yeah, it's the tension in that tow bar. That's what's pulling it forward. I know of course the car is created the forward movement, the forward force, 8,400 or whatever it was, but ultimately that's connected to the tow bar, okay, and it's the tow bar that's attached to the trailer. So we look at what that force is in the tow bar that's pulling this forward. And now we know the acceleration is 0.923. Okay, we worked that out in part A. So the resistance is, well, if we're just focusing on the trailer, the resistance will just be 300, won't it? 300 newtons to the trailer. Okay, and then of course I've got the weight then of the trailer, 600 G, resolved in parallel to the plane, perpendicular to the plane. So if we again apply Newton's second law, okay, to the trailer, we'll have, so in the direction of motion, so it'll be parallel to the inclined plane, we'll have T, take away the 300, take away the 600 G sine alpha, okay, and that will equal to the mass, which is 600, times the acceleration, which was 0.923, which we worked out in part A. And then, of course, we know sine alpha was given to us was 7/25, so we just sub that in, 600 times 9.8 times 7/25 equals to that. Then it's a case of using our calculator to determine what T is. So I get my T out to be 2,500 newtons, okay?